Hi everyone. I know there was a presentation on this without any sound, but I know that some of you like the videos better. So I thought I would make one for comparing functions. So comparing functions just means that you're given two situations that are similar and you compare them. Like what is the better deal, or which is running faster, or so you're basically going to be comparing the y-intercepts, so where they begin, and their rate. So I'll start with this first problem. So the problem says, a zebra is the main predator. The zebra's main predator is the lion. Lions can run at a speed of 53 feet per second. So that gives us the rate of the lion. 53 feet per second. The graph at the right shows the speed of the zebra. And then it says to compare their speeds. So how can we find the rate of change for the zebra? I would say that we should choose 2 points and then use the slope formula. However, right here we are given the rate at 1. So we see the rate right there, 159. For 1 second, he's going 59 feet. So one way we could do this is look for the distance at 1 second, or use 2 points to find slope. So those are the 2 ways that you could find the rate from a graph. So what is the rate? 59 feet per second. So how do the rates for the lion and the zebra compare? We can say that since 59 feet per second, the speed of the zebra is greater than the speed of the lion at 53 feet per second. The zebra's rate is faster. The zebra's rate is faster. What is the y-intercept for the lion? Well, at 0, they're both 0. They're both 0. So their beginning point is the same. From this information, in real life, they're not going to be right next to each other. So you'd have to choose one. Probably the zebra is further away, so the lion would be 0 and the zebra would have a head start, is generally what we would think. But for our information right now, they're both 0. So what are some words we can use to compare functions? We can say, especially with the rate, we can say greater than, less than, the same, faster, slower. We could talk about increasing at a faster rate, increasing, decreasing. These are just some of the words that we could use to compare functions. And again, we're generally going to be comparing the y-intercept and the slope, but in context for the problem. So again, to compare, you're first going to pull out the rate and the y-intercept, and then you're going to make your comparison statement. A major mistake that some people have made in the past is just pulling out the rate and the y-intercept, but not actually making a comparison statement. Just restating what the rate and the y-intercept is. You have to compare them. Okay, so the rate of the car. A certain car has a gas mileage of 22 miles per gallon. So that's the rate. It's not how fast he's going, so it's really not the rate of how fast the car is going, but the rate at which they're using gas. Miles per gallon. And the y-intercept, at 0 miles, they're going to be using 0 gallons. Or at 0 gallons, they're going to be going 0 miles. So the rate of the SUV, how can we find that? Well, the rate of the SUV, again, we are given the number of miles driven for 1 gallon. If you were not, though, I want to just remind you that you could use this method. You name your 2 points, and you do the arrow trick. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Either way, we get 19 miles per gallon. And the y-intercept, it is going through at 0 as well. So 0 gallons uses 0 miles. So now let's compare. So 22 is greater than 19. So we can say the rate of miles per gallon for the car is greater than, so better than the SUV. Last example. Here you're given an equation and a story, so you have to pull out the information. Lastly, investigative services charges are shown below. So y equals 75x plus 200. So remember, we know that our y-intercept is the one without the x, and our rate is the one with the x. And you have to think about what that means. If their services the service charges, so their charges, what does that mean for this situation? Sean and Gus charge 100 up front. So remember, the up front or the beginning is the y-intercept. And 125 per hour, that's your rate. So how could we make a comparison? All of these are money, so I'm just going to put that in there. So comparison, 125 is greater than 75, but 200 is greater than 100. So lastly, we could say something like lastly, investigative services charges 100 more up front than Sean and Gus, but charges $50 less per hour. Something like that. So more than, less than, we talked about the rate and the y-intercept. I have my inequality statements right there. And what we would use this for is to justify which company we would use depending. So here, at first it's more expensive, but then it becomes, so here it's less expensive. Sean and Gus is less expensive at first. Lassie is more expensive, but at some point, because they're going up, the charges are going up at a faster rate for Sean and Gus, they're at some point going to overlap. So we could figure out, using what we know about solving systems, to solve this. So if we wanted to figure out when they would be equal, 200 up front plus 75x, x being the number of miles, when is that going to equal 100 up front plus 125? And we could solve that system to see when they would be the same, and up to the point where they are the same, Sean and Gus would be the better deal, but after the point that they're the same, Lassie Investigative Services would be the better deal. Okay, comparing. That's comparing. We out.